Thanks for having me here. So yeah, as so we got acquired by Mongo. It's a small amount for the AI standard, I think. We work on mostly on embedding models and rankers, just these two models. We just try to make these two models the best. They are the key components for the retrieval stack. So the retrieval system. Because of this, also because of my research at Stanford, we are kind of familiar with the RAG and the whole retrieval stuff. So that's why I'm spending some time talking about not only just the embedding models, but generally how to use embedding models to get the best retrieval quality and also get the best RAG quality. So I guess just for those people who are probably not 100% familiar with the area, so the thesis here is that large language model out of the box doesn't know enough proprietary information. You do have to retrieve or ingest a lot of data so that you can equip the large language model with additional context so that you can reduce the hallucination. You can just let the large language model to know more things so that they can answer the questions for you, right? So I guess I used to say large language models, and now I have agents in the parentheses. I guess just because agents are seems to be sexy. I guess RAG is probably less sexy these days, but sometimes when things are a little bit less sexy, it starts to be really useful. And we have seen very very fast growth of our models and generally fast growth of using RAG system. So I think it's becoming more and more mature in some sense, and we are solving a slightly different type of question, right? So at the beginning, the problem is how do you get the accuracy of the retrieval to be 70%, from 50%, right? So now it becomes like probably how do we improve from 80% to 95%, even to 99% in some cases. Of course, for some cases, I think for legal retrieval, at least in my understanding, we are still probably in the 80% or 70% regime. But for many other kind of retrieval tasks, we are in the 95% regime. Anyway, so just very briefly review some of the debate in the last 1.5 years on whether you should use RAG, fine-tuning and long context. I think some of this debate was, there are probably two debates, one around early 2023, maybe mid-2023, about RAG versus fine-tuning, and another debate about RAG versus long context around probably the middle of the last year. And I feel like most of the debates are actually settled to some degree. And I think they are settled in some sense in favor of RAG. Maybe of course, all of these methods coexist eventually, but I think RAG probably have the most applicability. So just very quickly, what's a long context transformer? It's very simple. You just have a query and you have a lot of documents. You dump all the documents. At least this is the long context transformer can do many other things as well, right? But I'm talking about how to incorporate or ingest a lot of proprietary data, and then in those contexts, how do you use long context to help with that? You just dump an entire large corpus to the context, and then you have a query, and then you get a response from the long context transformer. Fine-tuning means that you first, fine-tune the large language model with the corpus, and then you update your weights, use the fine-tuned weights, and then you just keep asking questions without any additional use of the corpus anymore. And RAG means that you do a retrieval search step given a query. So it's important that the query is part of the search, right? So given a query, you search some relevant documents, and then you send these relevant documents to a large language model together with the query, and then you can get the answer. So in some sense, the way I'm thinking about it these days is that, you can kind of like make an analogy between these techniques with some of how humans are solving certain kind of problems. In some sense, long context means that you skim the entire library to answer just one question. Every time you answer one question, you skim the whole library. I'm using the word skimming, but actually, in some sense, you read the entire library. Of course, if you sparse attention, maybe you are skimming, actually. Anyways, but you go through the entire library to answer just one question. And for fine-tuning, it's kind of like you muscle memorize the library in some sense, right? You update your synapses the neurons and synapses in your brain so that, you really just keep them in your neurons, right? So then, in some sense, it's difficult, in my opinion, and also it's unnecessary, right? Who really muscle memorize everything in the library. And RAG is kind of like you retrieve the relevant books or book chapters or paragraphs from the library to answer the question. So in some sense, you can see because of this characteristics, you can see the long context has enormous cost, and the quality loss due to lots of irrelevant context, and you have to go through this very long context very fast. You may be able to improve the efficiency, reduce the cost, but then maybe you also sacrifice the loss and the quality loss. And fine tuning is kind of like you need a lot of high quality data to really. All paraphrasing, I think we realized this very early on before even this debate happens, and that's one of the reasons why my startup heavily invests in the RAG path, and we work on the retrieval. So and also acquiring and forgetting knowledge is difficult, especially forgetting is kind of like subtle because even humans are very hard. Once they are in your synapses, I think it's hard to really erase them. So and for RAG, it's very reliable, it's very modular, it's very simple, kind of like a few components, and fast and cheap, and high quality responses and no hallucination. So the next part of the talk is about some of the current statistics of the RAG. So I guess just probably review this very quickly. Just I didn't talk too much about the retrieval part. Now I unpacked the retrieval part into the components. So the two components are the embedding models and the vector database. So you vectorize the documents into vectors, and you also vectorize the query, and then you use the vector database to do a k-nearest neighbor search, approximate k-nearest neighbor search to be precise, and then you retrieve some documents. Sometimes you can also add a re-ranker later, and then you send it to a large language model. So we have many successful cases where I use Continue because they are one of our users. And there are some significant improvement in the accuracy of the embedding models. This is what Voyage has done in the last 2 years. We can see that, I think probably 2 years ago, some of the tasks, the accuracy is on the order of like maybe 50%, and now they are improved to 70%. And sometimes before it was 75%, and we improved it to kind of 85, 90%. This is probably slightly under representing the numbers because we are using very kind of like hard retrieval tasks for evaluation because those has higher differentiation, right? So if you really randomly sample a task in your real world cases, at least from what I heard from the customers, generally their accuracies are higher than this, maybe on the order of like 80%, 85%. Yeah, but we just choose some more differentiating tasks for the visualization. But you can see at least there are so many tasks where the performance is not as good as 95%, which is probably what you really want. So it's not perfect yet. So then my talk is that how do you solve this problem? How do you make the retrieval quality higher, right? So 70%, 80% is good, but not good enough for modern AI. We are supposed to solve even very hard reasoning tasks, with even higher accuracy. Retrieval should have higher accuracy. So how to improve the RAG performance? Besides just using better embedding models, which is one of the way. So I think one pretty common way I think most people probably know is that you use this hybrid search and re-rankers. So basically you do these embedding models at the beginning, the first a few components I've shown, and then you add a re-ranker, and this re-ranker, first of all by itself can fine tune or polish the results or refine the results, and also you can combine with other hybrid search results like a keyword-based search, so on and so forth. And you can aggregate multiple different search results, even sometimes aggregate the results from different embedding models, and then you get the final set of a set of results. So this is pretty common, and it's pretty much guaranteed to be useful. All the customers I've talked to, they found this to be useful. Another one is that you can enhance the queries and documents. This is nothing really new as well. But by the way, most of the things I'm talking about is not new, and I'm just selecting it from what people already know to some degree. So how do you kind of enhance the queries and documents? There are so many different ways. I'm just giving you some examples, and in many cases you do it based on the data the features of your data. So for example, if the original query is RAG, you can make the query longer, say explain retrieval-augmented generation to me, right? So and then there's a higher chance to map to words like retrieval, right? And you can also decompose the query into two queries so that you can have problem match into two type of kind of documents that are similar to the query in some different senses. And on the document side, you can also add document headers, document titles, categories, authors, dates, whatever you can think of, right? Sometimes for legal documents, you add the first paragraph to every future trunks because the first paragraph defines the entity, defines maybe some of the high-level context, so you copy-paste that into every trunks in the later part. So I have a list of this, so I'm going to go through them relatively quickly. So the second one is that you can use some of the domain-specific embeddings, which are optimized for different particular use case. This is kind of like a little bit advertisement for Voyage. So we build this code embedding model, which has much better accuracy on the code retrieval tasks. So this is trained on a lot of code data, and you can get much higher accuracy. I think one of the important things is that, especially if you think about some of the trade-off here, right? So here, I didn't talk too much about what this relative storage cost means. So here we are using this Matryoshka learning algorithm and some of the quantization-aware algorithm to provide a family of embedding models with different dimensionality and different precision, so that you can reduce the storage. And we have done this for many different things. For code embeddings, for general purpose embeddings, and we found that the trade-off for the code embedding is much more lenient, or much more kind of like a flat in some sense, right? So because you optimize for only one domain, you can also use relatively lower dimensional embeddings and lower precision quantization without too much loss of the accuracy. And if you look at the general purpose plot, it's more like it's a sharper job when you use lower dimensional embeddings and precision. And another thing is that you can. Okay, so the third idea is that sometimes people are doing trunking and doing a lot of pre-processing. So and also dealing with PDFs. So the way to do it is that you first, for example, to deal with PDFs, you first find out some layout, you do some parsing, and you turn images into description of images, you turn tables into description of tables, videos into transcripts, so on and so forth, and then you somehow trunk the long text into different parts. And sometimes this whole pipeline is called unstructured data ETL, and you do some kind of customized things for your data, for different type of data. So basically, as this shows, right, so you're taking multiple different type of data, and you do some layout analyzer, you do some parser, transcription, and then you do embedding models. You can also fine-tune the embedding models. This is kind of like you are training a customized librarian for a special library. For example, if it's the chemistry library, I think the librarian needs to speak the chemistry language to some degree and understand better the details. And there are many different ways to train this customized embedding models. Generally, you need to find out some of the pairs. They call positive pairs. In the technical term is positive pairs. Basically, they are pairs of data that are supposed to be somewhat related. They don't have to be extremely related, right? So it could be title header versus the document. It could be question and supporting evidence, caption versus image, query versus document. So basically anything that are supposed to be a little bit related, you can try to use them to fine-tune your embeddings, and with the so-called contrastive learning loss, and generally this improves the performance. Another one. So this is what published by Anthropic, which I really think is very interesting, but I have a slightly better idea later on. So this is published by Anthropic. So they say that, each of these trunks, for example, you have a 50-page document, and you trunk it into probably like 50 trunks, and then in the last trunk, you already lose some of the context, in the first page, right? So basically, every trunk needs to be augmented by some of the global context. Especially for legal documents, right? So the 50 pages of the legal document needs to be augmented by some of the global information about the context. So what Anthropic proposed is that you first trunk them, and then you use the large language model to generate context that you can add to each of the trunk. And how do you generate the context? You do some prompting. You say, can you generate some of the context which are useful for all the trunks? And then you prepend them into each of the trunk, and then you do the embedding model. So number 6, the last one. So I think I'm listing a few of this. I think there are even more and more which I'm not keeping track of. So there are many different variants of RAG where you can do all kind of other stuff. For example, you can do recursive RAG where you recursively retrieve documents, and there are many other ones, graph rec, speculative rec, corrective rec, which I'm not going to. My somewhat biased opinion, I've tried some of this, myself. I've heard some of the customers, talking about them. Definitely they are useful for some cases, but I'm not that convinced that they are always useful for all cases. So it becomes a little kind of like, to some degree, a little bit ad hoc to some degree, right? So like it depends on whether you believe that the particular approach suits your data to some degree, and you do have to have some good evaluations that is not biased towards the approach in some sense. Yeah. So that's what I see as the kind of the general landscape of RAG these days. And I'm going to spend the next probably like 15 minutes, maybe 13 minutes to talk a little bit about what I see as the future. So I think, and my one-liner is that AI models need to do more work. Let me try to build a case here. So let's go back to foundation models or generative AI, right? So I think prior to generative AI foundation models, I think I teach at Stanford as well. So I had this. I teach this course, that Andrew Yin has been teaching for a long time. So I started to teach it as well after I joined Stanford in 2018, and I co-taught it with Chris Ray. And I think that I remember the first quarter I was teaching it, I saw this existing slides in the slide stack, I think which was made by Chris. So there was one lecture about how to build ML systems. This is back in 2018, 2019. So, and this is the 7 steps that Chris wrote in his slide stack. Acquire data, look at your data, and you do that after every step, and you create train dev test split. You create and redefine your specification, you build models, you do measurement, and you repeat. So, and you do these steps, actually you can repeat in different levels, right? Probably you go back from step 5 to step 3, and then you repeat in many different ways. So, and these days, in 2024, 2025, right, so you probably should just use large language model out of the box without doing any of this as a user of the models, right? So all of these steps are still what we are doing in Voyage, or what people are doing in OpenAI, Anthropic, XAI, so on and so forth, right? When you are training the model, you still have to go through all of these steps, even probably more steps in some sense. But from a user perspective, you pretty much only need to just treat the large language model as a black box. The only thing you have to customize is to just add more prompts in some sense to instruct the large language model to do something special for you. So, and you probably need to do RAG to incorporate or ingest proprietary information. So, so I think this is the trend, and this is how GPT-3 is very, very different from BERT. This is how this new wave of large language model is very different from the previous wave of AI. So, and I think the same thing should happen to RAG. And let me walk you through about this kind of vision or argument. So I think what happens right now with RAG is that there is, of course, a computing infrastructure layer. I'm broadly keeping everything about compute there, like GPU. Even KNN is kind of like a computational tool. So this is the computation infrastructure, and there is a layer where you have the models. This is a machine learning problems you are trying to solve with the models, right? You care about the accuracy, versus the latency, so on and so forth. And then people use a lot of tricks on top of these models, right? Parsing, trunking, extracting data, recursive search, contextual trunks, graph rec, so on and so forth. So these are the kind of like the complex multiple steps, you have to iterate over to find out to make the performance the best based on your own data. So my vision is that the models should do more work. It should be more kind of like out of the box. And the reason why it's not the case is just because currently the embeddings are still not good enough in some sense. So, so my hope at least is that the tricks will be reduced, and the models will be stronger, and it's a much cleaner and standardized and mature kind of like paradigm, so that everyone can just plug in the embedding models and with the right config, and then you solve your problem very accurately. So in the next 5 minutes, I think I'm going to talk about a few kind of ideas towards this vision. So recall that we talk about this kind of custom parsers, extractors, or trunking, right? So these are mostly for multimodal data. And I think if you have the vision is that you can replace all of this by multimodal embeddings and you remove some of the steps. So the first way to remove some of the steps is that you say, oh, I'm going to interleave the text and images. Recall that before there's one more step, which is that you do the transcription. You turn everything into text. And now you don't have to turn images into text at least, right? You're just taking images and text together. So that's still not kind of like convenient enough. You have to still do PDF layout analyzer, PDF parser, so on and so forth. So what is really nice would be that you just take a screenshot of the PDF, the page, and then you just vectorize directly. And this is what we can do now. So we found that actually surprisingly, the models are very good at this. Right? The accuracy with the screenshot approach is not worse than using the best PDF layout analyzer and PDF parser and then going through the model, the multi-model embeddings. And if screenshots are good, you can do many things, right? You can do screenshot of the stat stack. You can do screenshots of anything that people see, right? And you can even take videos, because videos you can just take different frames, a sequence of frames and give it to the embedding model. So that will dramatically simplify this pipeline. Speaking a little bit about technical details here, right? So some of the existing embedding models have this issue called mixed modality issue. Roughly speaking, the main source of the issue is that if you look at the images and text, when they have the exact same meaning, they can still be very far away. So here is the example. You have some text, right? And also you have some screenshot of the text. And then you look at some of the existing embedding models, the vectors are actually very far away. And this will make the retrieval very unreliable because depending on which modality you are using, you get different results. So, and you lose the accuracy. So we have this Voyage multimodal 3, where we address this issue. Concretely, we actually evaluate this mixed modality retrieval issue by mixing images and text. And we found that no matter how you mix the images and text, the performance remains the same, right? It doesn't really depend on the mixing ratio between the images and text. And also we evaluate on different type of evaluation data sets, especially for this document screenshot setting, where we take screenshots of PDFs, images, tables, slide stacks, so on and so forth, and we can see very good performance. Okay, moving on to the next one. So this is about a future product we are going to release in 1 or 2 months. So recall that when Anthropic proposed this, they use this large language model to generate context, so that each trunk can have some context about the other trunks, right? Some global information. So and I think this is a great idea, but it could be simplified even more. So to this. So in some sense, the embedding model should be able to figure out the global information if you send the long document to the embedding model. It doesn't have to involve a large language model. In some sense, the embedding model also have a transformer under the hood. It should be able to do all of this as well. So the new interface is that you just send me a long document. The embedding model will do some automatic trunking, or maybe you can instruct me the embedding model on how you want to do the trunking. So the embedding model will trunk the data, and it will return one vector for each of the trunk. Nothing special yet, right? But what's special here is that the vector not only captures the information in that corresponding trunk, but also captures global information about other trunks. So vector 1 has a lot of detailed information for trunk 1, and has some high-level, less detailed information about trunk 2 to 5. So this is a right balance, because you need a little bit both of this to do the best retrieval. And we're going to release this in a few weeks, maybe not a few weeks, but like maybe 1 or 2 months. And we already have trained the model, and it has a great performance, especially for these cases where you have long document and you do need like global information, right? So, and with this, you don't have to think about how do I augment a document or the trunk, right? So you don't have to always add your title to all of the trunks in that document. You don't have to add authors' names to all of the trunks, and sometimes automatically those are captured here. I think another one is just that, you know, we are going to release some of the fine-tuning of the API so that this is easier, so that you don't have to fine-tune yourself, and we can optimize end-to-end the fine-tuning pipeline, so on and so forth. I guess that's everything I have. This is just a short recap and some of the QR codes for our website. I guess I have 5 minutes for questions. Thanks.